Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 2 to the power of 24. So to solve this, I'm going to first start by rewriting 2 to the power of 25 as 2 to the power of 24 plus 1. So I have this minus 2 to the power of 24. And the reason I did this is because we want both of these to be the same. We want to have 2 to the power of 24s. So the best way of changing 2 to the power of 25 as 2 to the power of 24 times something is to rewrite this as 2 to the power of 24 plus 1. So now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So now 2 to the power of 24 plus 1 turns into 2 to the power of 24 times 2 to the power of 1. And I still have this minus 2 to the power of 24. Now, from here, what I'm going to do is factor out 2 to the power of 24, because notice how both of these terms have 2 to the power of 24 in them. So, I get 2 to the power of 24 times 2 to the power of 24 times 2 to the power of 1 divided by 2 to the power of 24 is just 2 to the power of 1. And negative 2 to the power of 24 divided by 2 to the power of 24 is just negative 1. So I get 2 to the power of 24 times 2 to the power of 1 minus 1, which is equal to 2 to the power of 24 times 2 minus 1, which is equal to 2 to the power of 24 times 1. And this is just anything times 1 is obviously just equal to itself. So this is just equal to 2 to the power of 24. Now, from here, I'm going to rewrite this as 2 to the power of 12 times 2. So, the reason I did this is because I can now use the property a to the power of m times n is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is equal to 2 to the power of 12 to the power of 2. And 2 to the power of 12, well, 2 to the power of 1 is equal to 2. 2 to the power of 2 is double of 2 to the power of 1, so 4. And 2 to the power of 3 is double of 2 to the power of 2, which is 8. So this pattern goes on, and I keep on doubling this. Until I reach 2 to the power of 12, which is equal to 4,096. So this is my value for 2 to the power of 12. So now I get 4,096 squared. Now, what most people would do, well, first of all, 4,096 squared is the same thing as 4,096 times 4,096. And from here, what most people would do is they would just multiply this like this. So they do 4,096 times 4,096 and use the conventional method to multiplying it. However, this method takes way too long, and it's really easy to make an error using this method. So instead, to more easily solve this, I'm going to rewrite this as 4,000 plus 96 times 4,000 plus 96. And now I can use the distributive property. So I get 4,000 squared plus 4,000 times 96 plus 4,000 times 96 plus 96 squared. Now, from here, $4,000 squared, well, this is simple because all we have to do is 4 squared, which is 16, and then 1,000 squared, which is a million. So a million has 6 zeros, so all we have to do is add 6 zeros to the end of this. So I get 60 million, it's 4,000 squared, plus 4,000 times 96. Well, 4 times 96 is 384, so then all we have to do is add 3 zeros to that. So I get 384,000, and then this should be 4,000. So plus, again, 4,000 times 96, which is 384,000, plus 96 squared, which is 9,216. So now all we have to do is add all of these up, which is fairly simple. So I get 16 million plus, let's first start by adding up 384,000 plus 384,000. So that's going to be 768,000 plus 9,216. And now this is equal to 16 million plus 768,000 plus 9,216, which is 777,216. And now for my final step, I just have to add this to 16 million. So we don't have to worry about the millions place, so I just get 16,777,216. So this is my answer to this problem. Now, if you haven't already, please make sure to subscribe and leave a like, because I have many more videos like this on my channel, which you guys can try to solve. And if you're up for challenges, I have a bunch of those as well. So please make sure to subscribe, and thank you. Bye. Alright, so in this video, I'm going to solve the problem 3 to the power of 13 minus 3. So to solve this, I'm going to first start by rewriting this as 3 to the power of 12 plus 1 minus 3. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So I get 3 to the power of 12 times 3 to the power of 1 minus 3. And from here, I can factor out 3. So I get 3 times 3 to the power of 12 minus 1. Now 3 to the power of 12, I'm going to rewrite as 3 to the power of 6 times 2. And that's equal to 3 times 3 to the power of 6 to the power of 2 minus 1 squared. And I'm writing this like this because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into 3 times 729 plus 1 times 729 minus 1. This is equal to 730 times 728 . So from here, I'm going to rewrite this as 700 plus 30 times 700 plus 28. So this is equal to 3 times 700 squared plus 700 times 28 plus 30 times 700 plus 28 times 30. Now this is equal to 3 times 490,000 plus 40,600 plus 840, which is equal to 3 times 531,440, which is equal to 1,594,320. So this is my answer.